Hey, and welcome to the second video. And I'm going to show sort of like, here's PolyWalk in action on something that I'm doing. And so, just, put in some text. I don't know what this is going to be, but this is, the motion graphic. And maybe I'm going to build the text this way too and have everything like moving. It's rather static. I need that stuff, just, slight movement to it, like the background. So that's what PolyWalk does. That's why I'm building PolyWalk. So let's I shouldn't have had my email up there. Hopefully there's, don't go snooping. So here is the polygon, so I'm going to template that right now. So this is the mesh that we're bringing in. And so we're going to be, on this video, just talking about the connection network. Now, what we have to do is we have to promote the primitive ID onto each one of these points, because these are all faceted. Every triangle is its own triangle. Next thing we do is initializing a vertex ID. For a vertice attribute, and this is setting the primitive vertex, so a 0, 1, 2 pretty much on here, because what we got to do is when we build a connection, we need the opposite vertice of the connection to animate these pieces. So that's what we're setting up here. Now, so this is how you do that. This is how you build the primitive vertex number. And so in primitive with three vertices, you get 0, 1, 2. Alright, so the next thing we got to do is we take all these triangles and we cut at all internal U breakpoints. And what that does is that turns every primitive into all triangles into 3 lines. So you can see here primitive 614 to 1842. I'm going to stop talking so fast. So this is how you compute the opposite vertice right here. So what this is saying is for every line, get me the vertex ID. And so for every line, I'm just going to shrink these so you can see how I have a line here. Get the vertex ID, so of this point and this point. And so as you can see here, that's what we're doing. So that's the vertex index. So that gives me 0 and 1, or maybe it's the other way around, I don't know. And then give me this attribute. In fact, yes, I did have to do this. All right, now what this little equation does is I found that just working with the numbers, no matter what, if you take your the vert ID, so you have 3 numbers, 0, 1, 2. No matter what combination they are, like 0 plus 1, 1 plus 2, 2 plus 0, in any order, because you don't know what order these are in, you're going to get the opposite number. So if you have 0 and 2, this equation is going to give you 1. If you have 1 and 2, this is going to give you 0. So, 2 plus 1 is 3. Is 2 minus 2 gives you 0. So that's going to give you the opposite vertex. Otherwise, you got to do this long if, vertex ID equals 0, 0, or the vertex 0 equals VID equals 0, all this bullshit that you don't want to do. So next thing we got to do is each one of these lines now need a primitive ID of their own to communicate with one another. And so that's where I'm going to make primitive ID 2 and put the primitive number in there. So now the lines can communicate with each other. Now I shrink them down, and now you see for every line it gets shrunk to the center point. I'm going to promote the primitive ID to the point because I am going to remove the primitive and put a point in it instead, and I'm going to copy I'm basically copying the point. So and then removing the primitive. So I get 1 point per primitive with all the attributes carried over with this. On the second branch, I fuse them together, so all these points, there's like 4 points there, they become 1. And then the near point, and then I add them together. Now this should start to really look like the Verneuil connection network that I've done in other videos. I think I've uploaded those. It's pretty much the same thing. You're just basically building a connection based on an interface. Verneuil is 3D, this is 2D. So this transfer opvert, this basically is using the primitive ID attribute which we set here, which carries through here, and it's going to grab the opvert opposite vertex attribute that we have here. I'm going to clean up the geometry, remove some attributes that I don't need, and then set the position. And so as you can see, if I template my geometry again, we have a nice clean network. Now it's important to know that what we're setting up here is every triangle is going to talk to one primitive, and the last vertex on that primitive. That's very important. So in the next video, we're gonna build that structure, and that's built with the pathing. Thank you for watching, and if you like this, Bitcoin. I'm not going to promote that too much, but it would be awesome. Thanks.